This is Audiommunity, a podcast about our body's never-ending fight with the outside world. Welcome to Audiommunity. This is a Kevin Minisode recorded February 11th, 2015, and I'm Kevin Bonham. Today, I want to talk about chimeric antigen receptor T cells, or CAR T cells. And these are cells that a lot of people are talking about as a potentially game-changing cancer therapy. But frankly, I don't quite get it, and I'll tell you why in a sec. But before I do that, I just want to give you a brief introduction to cancer and the way that we normally treat it, the way that some people are thinking about using the immune system to treat cancer, which I think we've mentioned a little bit on previous episodes. But cancer, broadly speaking, is an array of different diseases that all have to do with abnormally reproducing cells. So normally, the cells in your body only reproduce at certain specific times. So if you get a cut on your skin, for example, you want the cells of your skin to be reproducing, and you slough off dead skin cells every now and again, and you want new skin cells to replace them. But if your skin cells are reproducing at an out-of-control rate, not dependent on the rate of sloughing or injury, then you can get a tumor. You can get basically a focus of cells that are reproducing out of control. And this is generally speaking what cancers are. And there's a couple of different types of cancers. I'm not going to get into all the details there. Normally, the way that we treat cancer is to try to use therapies or drugs that specifically target rapidly dividing cells. In a normal human body, there aren't a ton of cells that are rapidly reproducing. So if you give drugs that kill rapidly reproducing cells, the goal is to kill off the tumor cells sooner than you kill off normal cells. And of course, there are a lot of side effects to these treatments because they're not super specific. Cancer cells are our own cells, so any drug that can potentially target a cancer cell can also potentially target a normal cell. So a lot of the side effects of chemotherapy, things like nausea that come from the cells in your stomach not being able to reproduce, or killing off the reproducing cells in your stomach that normally replace that lining, or hair falling out because the cells in your hair follicles need to be reproducing pretty constantly. And so this is generally a problem with cancer therapies, that you need to target the tumors, but the tumors look so much like your own cells that it's really hard to be specific. And a couple of people in the past decade or decade and a half have been coming up with some other targeted therapies to try to target cancer cells specifically. So one example is a class of immunotherapies that use antibodies that target specific, what we call tumor antigens. So these are things that are only produced on tumor cells, or are produced mostly on tumor cells. One example of this is if you have a B-cell tumor, so you have B cells in your blood that are reproducing out of control, you can use an antibody to a molecule called CD19 that is principally produced on B cells, and treating a patient with this antibody, infusing it into the blood of a person with a B-cell lymphoma, will cause the immune system to target B cells. Now, unfortunately, the CD19 antibody will target all of the patient's B cells, but in a person with a B-cell lymphoma, generally speaking, most of the B cells in that patient end up being the tumorous B cells. So you kill off all the B cells, and that kind of sucks, but at the same time, you can eliminate the tumor pretty effectively with this drug. There are a couple of other examples of cancer therapies using antibodies, most notably for things like melanoma, but there's a limitation, and that is, again, you need to have something that is specific for a tumor cell. So a melanoma, for example, is a tumor of melanocytes, which are these cells in the skin that produce the pigment melanin, and antibody therapies work for these types of tumors because melanomas tend to have really, really unstable genomes. They tend to produce a lot of abnormal proteins that we can produce antibodies that recognize them specifically. So in other words, in a healthy melanocyte that is not tumorous, or is not cancerous rather, these antigens would not be produced. Whereas in the melanoma cells, the antigen is produced. So the antibody to this tumor antigen will only target the melanoma. Unfortunately, for many cancers, there aren't obvious tumor antigens, so these immunotherapies have somewhat limited utility. You need to have a very specific type of tumor. You need to be able to identify specific tumor antigens that are different in the tumor than in the normal cell. So that hopefully gives you a brief introduction, in case you didn't know, about tumors and immunotherapy. So I'm going to briefly talk about these chimeric antigen receptor T cells, or CAR T cells, because there's sort of a variation on this theme. So the way that these immunotherapies, like the anti-CD19 that I just talked about, work is when our cells are bound by antibodies, the immune system recognizes these things as potentially dangerous. So you have a B cell, it's expressing CD19, it gets stuck with an anti-CD19 antibody, or actually a lot of anti-CD19 antibodies, and then other cells of the immune system recognize the presence of that antibody and say, oh, this is dangerous, let me kill it. So you can have macrophages that engulf the cell, you can have NK cells that get targeted and do something called antibody-dependent cytotoxicity. And this works pretty well. But it would be really nice if we could target another part of our immune system, T cells, specifically CD8 positive killer T cells, to go after tumors. And we've mentioned CD8 positive T cells before. These are the cells that use a TCR receptor, recognize peptide bound to MHC in usually an infected cell, and then release toxic chemicals that convince those cells to commit suicide. So what a few people have done is to say, well, getting a T cell receptor that recognizes a specific peptide MHC on a tumor cell, that's a little bit complicated. But what if we could take the machinery of a T cell and attach the receptor from a B cell, in other words, the antigen recognition of a B cell or an antibody, and couple that to the cytotoxic killing of a CD8 positive T cell? And that's exactly what they did. So these chimeric antigen receptors are essentially the extracellular portion of an antibody and the intracellular machinery of a cytotoxic T cell. So you get a T cell that looks like a T cell, behaves like a T cell for all intents and purposes, but the way that it recognizes what cells to attach to an attack is not through a T cell receptor, but is instead a B cell receptor. Hopefully that's clear. And the idea here is that, again, you're taking something like that anti-CD19 antibody and you're coupling to that all the strength and power and killing properties of a cytotoxic T cell. And that's pretty cool. And a couple of these therapies have been developed. I've been using CD19 as a specific example because this has been done and has been very effective. And a lot of people are really excited about the prospect of making more of these CAR T cells to treat various types of cancer. The problem, though, the reason that I'm a little bit skeptical of this, or not skeptical of the potential utility of it, but I guess skeptical of some of the, revolutionary claims made by some people, is that you still need a tumor antigen. You still need something that identifies that cell as a tumor cell rather than a non-tumor cell. And we can do this for a lot of different types of tumors. I mentioned CD19, you're going to have these off-target effects. You're going to target, normal B cells, and that's okay because it's more important to kill off the tumor. For melanoma, you're going to have these cancer antigens you can go after, but there are a lot of tumors that don't express obvious tumor antigens, or they don't express them to the point where we think that they will be targeted by antibodies. Otherwise, people would be using antibody-based therapies already. Personally, I'm a little more bullish on the idea of a cancer vaccine, which we've talked about before, and this is the idea of you take a tumor out of a patient and you take immune cells, including antigen-presenting cells and T cells, out of a patient, and you sort of mix them together and you trust the immune system to find the antigen. So they could do this through a TCR peptide MHC interaction. This has the benefit of having a lot more potential antigens. Antibodies and these chimeric antigen receptor T cells can only recognize things that are on the surface of cells, whereas T cell receptor peptide MHC interactions allow T cells to sort of look inside the cell. And so it's hard to engineer these interactions, but if you can pull the stuff out of a patient, sort of let the immune system do its thing, figure out what the tumor antigens are on their own, I think that's a little bit more promising. Of course, that takes a lot more effort and it's possibly a bit more expensive. And don't get me wrong, I think the idea of a CAR T cell is cool. I just don't know that the utility of a CAR T cell over the immunotherapies that we already have is sufficient to get really super excited. I mean, it's exciting. Any new therapy for cancer is potentially a really good thing, but I think a lot of people are getting really excited about it. There's been a lot of high-profile publications about these CAR T cells that, to me, seem a little bit overblown. And maybe I'm wrong. Maybe I have no idea. I don't follow this field super closely. So if you understand why CAR T cells are potentially so exciting and I'm just not getting it, please let me know. Write in to Kevin at audiommunity.org. Or if you agree with me that this is sort of silly, this sort of hype that's been around these things, email that as well. And that's it for my first real Minisode. I'm Kevin Bonham, and this is Audiommunity from emunity.org. You can find this episode and all other minisodes and main episodes at emunity.org. That's EMMUNITY.org. As I said, you can send me an email, kevin@emunity.org, and we'll see you next time.